Welcome to The Explainer. Today, we're going to pull back the curtain on a secret mathematical language. It's one that's hidden all around us in the natural world, a code that shapes pretty much everything, from the tiniest seed to the biggest galaxy.
Okay, so what could a simple curling vine, a seashell, and a massive spiraling galaxy possibly have in common? I mean, on the surface, absolutely nothing, right? But it turns out so many of nature's most beautiful designs, well, they all follow this surprisingly simple hidden pattern. And trust me, these repeating shapes are anything but random.
Yeah, these patterns are no accident. They're basically expressions of an underlying code, like a quiet set of instructions that governs how life grows, how it takes its shape, and honestly, how it manages to be so beautiful.
And this code? Well, it has a name, the Fibonacci sequence. The rule behind it is so simple, but what it creates is this incredible hidden structure that connects, the smallest leaf to the largest shell. It's like they're all marching to the same silent numerical beat.
Okay, so here's how it works. You literally just start with 1 and 1. Then you add them together to get 2. Now take that 2 and the 1 before it, and you get 3. Then 2 plus 3 is 5. 3 plus 5 is 8. And you just keep going. It creates this sequence that just grows and grows. Kind of like, well, something growing out in nature.
So, that's the math, but where do we actually see this stuff? Well, let's start our tour in the plant world, because this is where the code really comes to life in some pretty amazing ways.
Just go outside and look at some flowers. Seriously, count the petals. So often you're going to find the count is a Fibonacci number. 3 petals, or 5, or 8, or 13. And it's not just to look pretty. This perfect symmetry actually creates a great landing pad for pollinators like bees and birds.
And okay, the sunflower might just be the most mind-blowing example of this. If you look closely at the seed head, you'll see these 2 sets of spirals, right? They curve out in opposite directions. Well, if you actually count them, the number of spirals in each direction, there are almost always 2 Fibonacci numbers that are right next to each other in the sequence. We're talking like 34 spirals going one way and 55 the other. It's wild.
And it's the exact same idea with a simple pine cone. Check out the scales. They're arranged in these overlapping spirals that also follow Fibonacci numbers. And why? This precise arrangement creates the tightest possible overlap, which is just brilliant for protecting those precious seeds tucked away inside.
All right, so this pattern is all over the plant world, for sure. But it doesn't stop there. Let's jump over to the animal kingdom, because you're going to see the same mathematical blueprint showing up in their designs too.
Think about a seashell, like the nautilus. It grows in this gorgeous, ever-expanding spiral. And the genius of this design is that the shell can get bigger and bigger as the animal inside grows, but its basic shape never, ever changes. It's just the perfect architectural solution for a growing creature.
And it's not just shells. You see it in horns and claws all the time. Think about bighorn sheep, or even some reptiles. They grow in that same spiral shape. And again, this isn't for looks. That spiral is a feat of engineering. It spreads out any impact or stress evenly, which makes those horns and claws unbelievably strong and tough, whether they're used for fighting or for digging.
Okay, so let's pause for a second. We've seen this pattern everywhere, in flowers, seashells, horns. So the big question is, why? Why does nature favor this pattern so consistently? What makes this simple string of numbers so fundamental to the design of life?
Well, it really all boils down to one word: efficiency. These aren't just pretty patterns for the sake of being pretty. Oh no, they are time-tested evolutionary strategies for survival. This mathematical code just happens to be the best way to pack seeds tightly, to get the most sunlight on your leaves, or to build the strongest possible structures. It's basically nature's own blueprint for thriving in a competitive world.
So you see, the Fibonacci sequence isn't just a fun math trick. It's way more than that. It's a fundamental principle of growth and design. It's what connects the smallest things, like a single cell, to massive weather systems like hurricanes. It's this quiet testament to the deep connections between life and mathematical order.
And here's the best part. Once you know about this code, you really start seeing it. You'll spot these beautiful, intricate patterns everywhere you look. It's a powerful reminder that there's a hidden order woven into the very fabric of life itself, patiently waiting for us to just look a little closer.